Namaste student. Today we are going to find zeros using the relationship between zeros and coefficient. So here we have relationship. We can recapitulate here. For quadratic polynomial, sum of zeros equals to minus b by a minus b. Here b is what? Coefficient of x, and a is coefficient of x square. And product of zero equals to constant term by coefficient of x square. So similarly we have two more relationship for cubic and for biquadratic. So here today we're going to use biquadratic relationship to find the zeros. Okay, let's start. We're going to use these two. Here we have minus b by a and other is e by a, that means constant term by coefficient of x to the power 4, and here we'll get minus coefficient of x cube by coefficient of x square. Okay, so here we have. So I'm going to solve this one, and you try by your own this one using this method. So let's start. Here we have given what? 2 plus 3 and 2 minus root 3 are zeros. This they have given, and what we're going to do, let alpha and beta be required zeros of what? Polynomial, right here, x to the power 4 minus 6x cube minus 26x square plus 138x minus 35. Okay, now then what? Then we know that sum of zero, what? Sum of zeros equals to minus coefficient of x cube by coefficient of x to the power 4. So here sum of zeros imply alpha plus beta plus 2 plus root 3 plus 2 minus root 3, and this side will get minus coefficient of x cube is what? Minus 6 by coefficient of x square is what? 1. Here you can see minus 3, minus root 3 and plus root 3 will cancel each other, and we'll get here alpha plus beta equals to what? Minus minus plus 6, and there is a plus 4, and if we'll take this plus 4 this side, it will give you 2, and this imply alpha equals to beta minus, not beta, sorry, 2 minus beta. This is your number 1. Next relationship, product of zeros. So product of zeros will give you what? Constant term by coefficient of x to the power 4. This means alpha into beta, and rest will be what? 2 plus root 3, 2 minus root 3 will give you constant term here. What we have? Minus 35. So here we have minus 35 by 1, and look at here, a plus b, a minus b will give you a square minus b square. This will be 35. Next, so here 2 to the 4 minus 3 will give you 1. That means this imply alpha beta equals to minus 35. So we'll substitute here alpha with the help of this equation 1. So alpha equals to 2 minus beta. So we can write instead of alpha 2 minus beta, and here we are getting beta minus 35. So you multiplied here 2 beta minus beta square equals to minus 35, and here we're going to get, take this all that side. Okay. So what we have? Beta square plus beta square minus 2 beta minus 35 equals to 0. This will give you beta square minus 7 beta plus 5 beta minus 35. So how? Use the splitting method, midterm splitting method. Multiply these two, we are getting minus 35. Break this one such a way so that we'll get minus 35. So here we have beta common, beta minus 7, here 5 common, beta minus 7. So we are getting here beta minus 7 and another is beta plus 5. Give it 0. This implies beta equals to 7 or beta equals to minus 5. So here we have two cases. Case 1, when beta equals to 7, we are getting alpha equals to what? 2 minus beta. That means 2 minus 7 will get here minus 5. And if we'll take case 2, beta equals to minus 5, we'll get here alpha equals to 2 minus 5 will get here 7. That means therefore zeros are minus 5 and 7. This is our answer using coefficient and zeros relationship. Okay, thank you.